All right, so we have question 23 right here, 23 and 24. They're both related to inequalities. Okay. Right now, we are going to solve these inequalities by algebraic method. Okay. Now, I want to emphasize something about the word solve and the word solution, because a lot of people, they don't really understand what's the difference between solve and simplifying. So they just know that they have to do something. Solve means that you want to make the statement true. So when we say solve, we are trying to find out the value or values of x to make this statement true. Now, I'm going to teach you the algebraic method first. We'll go through that method. And afterwards, I would also teach you how to think about this through graphing. Okay, so that would be very helpful. Now, the way we will do this is that let's not worry about the equals. Let's not worry about the inequality sign. Let's go ahead and make it equal. Okay, because what's going on here is that we have an absolute value function. So if you remember from algebra 2, that's a V-shaped graph. And then we have 15 right there, 15 on the right-hand side. So I can imagine there's another graph that's 15. So what we are asking is that, hey, which part of the absolute value graph is less than 15? Okay, now we'll come back to this graph later on. But for the moment, let's just make it equal, okay? Because if you think about the negative and positive, that could be somewhat confusing, okay? So now what's the meaning here? Absolute value of 5x minus 10 and then 15. So we're basically saying that the absolute value of 5x minus 10 is equal to 15. That's what we are basically saying. Absolute value of 5x minus 10, it's equal to 15. But is the stuff inside the absolute value function, which is 5x minus 10, is that positive 16, positive 15, or negative 15? And we'll say, we don't know. We just don't know. And therefore, we'll say, well, let's go ahead and, actually, let's consider both scenarios. That 5x minus 10 is equal to 15, and 5x minus 10 equals to negative 15. Let's consider both scenarios. And then we say, well, if you go ahead and solve for each one, then you have x equals to 5, and then you have x equals to, if you add 10, you have negative 5, so x equals to negative 1. So we have these two values. X is equal to 5, x is equal to negative 1. So what you can do now, well, we call these critical numbers. Okay, well, they're very critical because they can actually tell us a lot of things. So this is 5, this is negative 1. So now these, well, negative 1 and 5 for x value would make it equal to 15. We make the left-hand side equal to 15, but we want it to be less than 15. So we say, well, let's test some numbers. Let's test some numbers. So we say, let's pick a value left of negative 1, less than negative 1. Let's say negative 2, maybe. So we think about 5 times negative 2 minus 10. Absolute value of that. 5 times negative 2 is 5 times negative 2, it's negative 10 minus 10. You have negative 20 inside the absolute value. So you have absolute value of 20, absolute value of negative 20, which gives you 20. Well, 20 is not less than 15. So this interval doesn't work. Okay, because if you pick a number less than negative 1, that does not show you the, that's not making the original inequality statement true. If it's not making the statement true, then that means it's not the solution. Now, what if you pick a value between negative 1 and 5? So we say, yeah, between negative 1 and 5, you would have, let's pick 0. 0 is an easy number. So 5 times 0 minus 10 inside the absolute value function. So you have 0 minus 10 absolute value. So absolute value of negative 10, it's equal to 10. 10 is less than 15. So we say, hey, this is a good interval. This is a good interval. Negative 1 to 5, it's a good interval. And then you have 5 or greater than 5. So pick a value that's greater than 5. So let's say 6. 5 times 6 minus 10, which is equal to 30 minus 10, which is equal to 20. Absolute value of 20, which is 20. 20 is not less than 15. So values greater than 5 would not work. So our solution in this case would be and only be negative 1 to 5, excluding negative 1 and excluding 5. Because if you put in negative 1, you would get 15, but we want the number to be less than 15. We want the left-hand side to be less than 15. So you do not want negative 1 to be included. So, so we use parentheses. And it says what? Use inequality and interval notations. Okay, so this is the interval notation. If it's an inequality notation, we will say negative 1 is less than x and less than 5. This would be the inequality notation. Okay. So that's how we decide the interval. So that's the algebraic method. Okay, that's the algebraic method. So now, what about the graphing method? I think the graphing method is quite important, especially if you are going to calculus and you want to do well on the SAT. So if you look at the absolute value function, you may want to think about, how do I graph this absolute value function if I have to? Okay, so you would make sure that you factor the 5 first. So on a pair of axes, so you will be able to tell that this is an absolute value function that's moved to the right for 2 units with a pretty steep slope, with a slope of 5. Okay, all right, that's the absolute value function. Oops, hold on. Okay, and then you have the other side of the inequality, which is 15. So you have this part. Okay, so this is 15. Y equals to 15. Well, if you just look at it graphically, which part of the absolute value graph is lower than the purple graph? Well, it has to be this portion. And since you found out the x values of the intersection, which is negative 1 and 5, so if you know the graph, and if you're doing the multiple choice test, which we are, then you can easily tell the solution, which is going to be between negative 1 and 5. It has to be, because graphically, it is showing you that that is the only portion of the absolute value graph being less than the linear graph of y equals to 15.